you please make sure that you have mute yourself and turn off your camera? Okay, thank you. So let's talk about the compound assignment operators. We've got what we call compound assignment operators. Sorry, just to wait for me. I want to use my mouse. Okay. So let's talk about the compound operators. I need the highlighter here. Okay. I think it's all set. Okay. So let's talk about the compound assignment operators. So there are actually 11 or so compound assignment operators, but only the 4 most commonly used. We've got these ones that we actually almost use on our programs. So we are going to talk about these compound operators. So we've got this example, which have actually created without the use of the compound operators. Like this one, where we have got our y being equal to y minus 6, and this one which will be x being assigned x plus 2 times 5. So we can write all these statements using the compound operators. In other ways, the compound operators, we use them just to shorten all these statements. So now with the compound operators, we can write y minus is equal to 6. If you say y minus is equal to 6, what is it going to do? Is just going to say y is equals to y minus 6, just like this. So we are going to replace this. We are going to take this negative sign here and put it here, and then we put a y here, just as base case that. Also, we can actually also write this one in shorthand using the compound operator plus with this assignment operator, where you can actually say x is equals to x plus 2 times 5. I think this one we have actually done this before in other programming languages. I don't know if there is any issue with this one. So the last 2 assignments give the same result as the first 2. These ones will give the same result as this one. I don't know if there is any issue with this one. I don't see any hint here. I think I can actually continue with our slide. We have what we call the relational operators. We have what we call relational operators in Java. So relational operators always result in a Boolean, which is true or false value. Whenever you use greater than, less than or equal to, greater than or equal to, or the equal sign and the not equal sign, it will actually result in what? In the Boolean value, which is true or what? Or false. Something like that. So there's what we call the equality operators. On equality operators, you'll be actually checking if 2 objects or primitive variables, you are just comparing them if they are equal, something like that. So Java also has 2 relational operators, sometimes called equality operators, that compare 2 similar things and return 2 similar things and return a Boolean that represents what's true about the 2 things being equal. So what we want is to compare 2 similar things, and then we return a Boolean if they are equal, which is a true or a false. So these operators are, we've got this one, equal sign. So in Java, I do not use this one to compare. We use this double equal sign. It will become our equal sign in what? In Java programming. Also, you use this one, exclamation with equal sign, for not equal. If you want to check if 2 variables are not equal or holding the same value, you use what? This one. Don't know if there is any issue there. So there are 4 different types of things that can be tested here. With these operators, with these 2 operators, we can test numbers, characters, Boolean primitives, and object references, variables. It's object references, variables. But if you want to compare the objects, you are going to see that you are not going to use this equal sign, but there is the equals method that you have to use. It's a method that you have to use for comparing objects. But for comparing object references, you can use this equal sign. Also, for comparing Boolean primitives or Boolean variables, you can use this equal sign. For characters, you can use this equal sign. For numbers, integers, float, double, you can use this equal sign, even the not equal sign here. So there's this issue in Java. You need to be able to differentiate the use of this equal sign and this equal sign. These 2 things are different in Java. This one we call it an assignment operator, and this one is an equal sign. So when comparing, when comparing, use the equal sign. This one, use this sign, and not this one, because this one, what we refer as equal sign in mathematics, will make the code fail to compile. It will become an error. Thus, this does not compile. I think I can actually give an example on this one. Let me see if I can share with you my, let me stop sharing this one. Let me share another window with you. You can confirm if you are actually seeing my IDE here.
Yes, we are.
Yeah, okay. So you are talking, let me declare my variable here. If I say int x is equal to 10, and then if you try to combine x, if you want to compare if x is equal to 10, and then you print out here maybe the value of x is, let's just write 10 here is 10. You want to compare, but if you look here, we've actually have an error, a compilation error. We've got an error here. Why? Because this equal sign, this sign does not work for comparing. We actually use it to assign variables, to assign values to variables or to objects or something like that. That's when do we use this sign. That's why we have got this error. So you need to put this equal sign so that you can actually, let me run this. So you see the value of x is 10. That's the difference between this sign and this sign. Don't know if there is any question there. I think I can continue. Let me stop sharing this. Let me share my initial slide. Okay. So don't mistake this one for this in a Boolean expression. Why are we saying so? This sign, you can use it for a Boolean expression only if you want to compare. It is legal to use this sign to compare, but only for Boolean expressions. So you use it for Boolean variables. The following is legal. Here, if you declare your Boolean variable b and assign it to false, you can also compare if Boolean b is true or false, and then you do what you want to do here. Otherwise, the Boolean is what? Is false. So the Boolean variable b is not being compared to true. It's being set to true. So the print line executes and we get b is what? Is true. So with this one, it will work here. It will work for Boolean expression. for comparing and do something. But for this equal sign, this one, but for this one, it will not work with other variable types. I think I can actually try to share with you so that we can experiment with it. Let me try to share my IDE here. Instead of using this integer, if I change this one to Boolean, and then here for Boolean, we take true and false only. So if I say if x is equal to, let me say false here, then do this, print that x is false, then I'll put the else part, sys out, then let me just say x is true. Then let me run this one. What do we get? We get what? X is true here. So that's what it is. You can compare using this equal sign only for Boolean expressions. But for other expressions, you need this one, this sign. Okay? So I think I can move on with our slides. Let me reshare my slide here. So let's talk about the instance of comparison. There is this one where you can compare the instance variables if it belongs to a class or also to another class or so. So the instance of operator is used. Can you make sure that all our mic are on mute? Let me try to mute everyone. Okay, so the instance of operator is used for object reference variables only, and you can use it to check whether an object is of a particular type. If you want to check it if it is a string, or if you want to check if it belongs to a certain class, maybe it's a class student, or it's a class for customers, something like that. So by type, we mean class or interface type in other words. So if the object referred to by the variable on the left side of the operator passes is a test for the class or interface type on the right side. Those are the test results. So we have this program where we are going to check if this S is a string object or it's of type string. So you can have all this, the public main method, and then you declare your string, and you know that all strings are objects in Java. And then from there, you use the instance of keyword here to check if S is an instance of string or is a type string. And then you say S is a string. Otherwise, S is not a what? It's not a string. This is how do you use the instance of. I don't know if there is any issue with this one. I think it's straightforward. Maybe we can move on to the arithmetic operators. These ones, I'm sure you are actually used to them. I'm just going to rush through. And you have been actually using them in C, in C++, maybe in other programming language that we have been actually doing. Because these are just the basic arithmetic operator. So we are sure you are familiar with the basic arithmetic operators, the addition, the subtraction, the multiplication, and the division. So there is the remainder, and it's also there in C and in C++, which uses the modulus or the percentage. One operator you should also be as familiar with is the remainder operator, or this percentage or the modular. The remainder operator divides the left operand by the right operand and the result is the remainder. Maybe we've got 4 divided by 2, and then what we want here is the remainder, which means it will be 0. This is what do we want from this remainder operator, or the percentage, or the modulus, the modular operator. We will be actually asking you to find the remainder after dividing the numerator by the denominator. So it will return a remainder. Like here, 2 into 4, then it will return 0 as what is our answer. Don't know if there is any question there. There is this other issue, which is also very important. In a Java, there's what we call string concatenation operator. So we use the plus sign for string concatenation in a Java. So the plus sign can also be used to concatenate 2 strings together, as we saw earlier, because we've got another method for doing that, but you can just use this plus to concatenate your strings. So string animal, we've got this string animal, which will be actually initialized to gray, then we add elephant to it, so it will be gray elephant. So string concatenation gets interesting when you combine numbers with the strings. You need to know that if you try to combine numbers with the strings, it will actually append that number to the end of the string. Otherwise, if you are adding those numbers to numbers, it will just add rather than doing the string concatenation. Okay, so there's the decrement and increment operator. I don't know if there is any issue with the issue of this one. I think I can proceed there without a demonstration there, just for the sake of our time. There's what we call the increment and decrement operators. Also, these ones are also available in C++ and even in C programming. So Java has 2 operators that will increment or decrement a variable by exactly 1. If you want to increment or decrement a variable by 1, there are these operators that you can use, which is a plus plus and a minus minus. So these operators are composed of either 2 plus signs or 2 minus signs. Plus plus increment, it's a prefix and post. There's prefix and post prefix, and there is a decrement operator, which is a prefix and post prefix. So the operator is placed either before, which is a prefix, or after, which is a postfix, a variable to change its value. So that's the meaning of these 2 words. You can either write a plus plus, or write plus plus a. So that's the difference of prefix. This one is a prefix and this one is post prefix. There is a slightly different meaning of these 2 things. It's just a slight difference. It's not that much bigger difference on how does it work, this one and this one. I will actually explain that. So whether the operator comes before or after, the operand can change the outcome of an expression. So before this one, let me just explain about these 2 things. Let me just erase everything here. If I say y be equal to a plus here, maybe earlier a was equal to 10, right? And then here let me say y be equal to be initialized plus a. So what does this mean? If I say what would be the value of y here after executing this statement? Here initially my a is equal to 10. So if I say a plus plus, what I'm saying is that first use the value of a and then add 1 to this one, or increment it by 1. So the value of y will be equal to 10. Why? Because at first I'll use the value of a before increment, which means it will be 10 here. Then later the value of a will become 11. So if you came here, if I execute this one, let's say we do not have this one, I'm going to execute this one. I've got plus plus a. I'm saying increment first and then use the value of a. So my y will become 11. So my AU first will be 11. I will increment it by 1 from 10, then it will become 11, and then I will initialize it here, then my y will become 11. That's the difference of a plus plus and plus plus a. I don't know if there is any question here. I think I can actually move on. We've got the conditional operators, So the conditional operator, I'm trying to add someone here. Do we have someone in waiting? It's fine. So the conditional operator is a ternary operator. It has 3 operands and is used to evaluate Boolean expressions, much like an if statement, except instead of executing a block of code, if the test is true, a condition operator will assign a value to a variable. There's what you call a conditional operator. So in other words, the goal of the conditional operator is to decide which of 2 values to assign to a variable. What we'll be actually doing, I think we've got an example here. This operator constructed we use a question mark to construct this conditional operator. So in these there are the issue of parentheses. These parentheses are optional. You can actually even leave them out or use them. So the parentheses are optional. Its structure is you can have this variable x here as a Boolean, and then you put the Boolean expression here. If x is equal to true, it's like you'll be actually using if statement. If x is equal to true or false here, maybe you can put it true or false, then you put a question mark. So it will check if x is that value that you have put here. Then you put the value here to assign if x is true. You if you put it true here, so if it is true, the expression here that we have here, then it will assign a certain value to x. Otherwise, if it is false, it will assign false here. Okay, to what? To x. This is how the conditional operator works. Though it actually you don't use it much. We've got what we call the logical operators. There's the short circuit logical operator. Let's talk about the short circuit logical operator. Once we talk about these ones, you know the other ones, it will be actually easier to understand them. So the short circuit logical operators, you normally use them when you are doing the loops, or I think when you're doing the loops somewhere there, you normally use them, or you are actually comparing things using if statements. You can actually use all these things. So there are 5 logical operators on the exam that are used to evaluate statements that contain more than 1 Boolean expressions. But the most commonly used of the 5 are the 2 short circuit logical operators. Let's talk about these 2 circuit logical operators, the short circuit AND and the short circuit OR. So they are used to link little Boolean expressions together to form bigger Boolean expressions. You might have single Boolean expressions that you want to join or to make a compound Boolean expression, then you use the AND or this OR operator. So this AND operator or operator, these operators evaluate only Boolean values. For an AND expression to be true, both operands must be true. Here, if you are using this AND, if we've got an expression here, then we put an AND here, and we've got another expression here. If you are using this AND, all these 2 expressions must be true for us to execute what actually comes in that block of code. So the short circuit feature of the AND operator is so named because it doesn't waste its time on pointless evaluations. What does it do? If it evaluates this one and then it gets true here, and then get false here, it doesn't actually goes on to evaluate this. Why? Because it's an AND. It requires this one to be true and this one to be true. So if this one is false, it doesn't matter whether this one is true or not. That's why it is actually called short circuit. end. So a short circuit end evaluates the left side of the operation first, which is the operand 1. And if it reverses to false, the end operator doesn't bother looking at the right side of the expression here, since the end operator already knows that the complete expression can't possibly be true. So this is how this end works. It is just the same as the OR operator. The OR operator is similar to the AND operator, except that it evaluates true if either of the operand is true. With this one, if we have got then we have got an OR here. We have got an OR here. If this one is true, if either of these ones is true, then it to actually execute what comes in that block. So if the first operand in an OR operation is true, the result will be true. So the short circuit OR doesn't waste time looking at the right side of the equation. So it actually checks here, and if this one is true, we know that the result of this one, it doesn't affect our outcome, because we actually require one of these to be what? To be true. So if the first operand is false, however, the short circuit is to evaluate the second operand to see if the result of the OR operation will be true or what, or false. So there's the logical operators, these ones which are not short circuit, which is just the single ampersand here sign, and then this one, this single pipe here for OR. What does this do? It actually evaluates both conditions or both statements that you have, then it will make a decision later. So it will actually look in both of your what, of your Boolean expressions. It will check this one and this one, then it will make a decision later. So these operators are used in logical expressions just like the and OR operators are used. But because they are not the short circuit operators, they evaluate both sides of the expression always. So they are inefficient. For example, even if the first operand left side in an AND expression is false, the second operand will still be evaluated. So this is the short form of using the not short circuit operators. So this is the end of what? Of Java operators. This is all about Java operators. I don't know if there is any question before we actually moved on to other lesson that we have to do. Or no, do we have any question? Do not see any hand here. It's all clear on this one. Let me stop sharing. I want to share another slide. Can we confirm is all clear on Java operators?
We were a bit late, said, but we wanted to
It's okay. So let's move on to the Java flow control. What my wish here today is to make sure that we'll be actually left with the encapsulation, inheritance, polymorphism, and so blah blah, so that we do the object oriented on our next lecture. So let's move on to Java flow control. This is the most interesting part as well, since you're actually using it to evaluate all your conditions, or also if you are executing your programs or so, something like that. So I'm sharing this slide, sorry. That way. So confirm if you are actually seeing my slide there.
Yes, it's clear, sir.
It's fine.
Yes, it.
Okay, it's okay. So let's talk about the Java flow control. Here, so we've got the if and the switch statements. These ones are the most common that we've actually been using. The if, the switch statements, the for loop, the while loop. But let's talk about the if and the switch statements. So the if and the switch statements are commonly referred to as decision statements. These ones, we have actually first to make a decision before doing anything. So when you use decision statements in your program, you are asking the program to evaluate a given expression to determine which course of action to take. You want to decide if you want to go left or if you want to go right. So there will be a decision here to make. So it will evaluate this decision, then the outcome from this, then you will be actually know which direction to take. So this is how to use the if and the switch statement. So the basic format of an if statement is as follows. I think when I was actually demonstrating, I was also using the if statement for the syntax of if statement. I don't know if there is an issue, if there is anyone who want me to experiment that also. So this one is the if statement. You put an if, then you put a Boolean expression here, which will result into true or false. If it is true, then we execute what is in these blocks. So after that, it will actually goes to the next line just after the if statement. So the expression in parentheses must evaluate to a Boolean which is true or false. This one is a must. It must be result into what? Into a true or a false, the expression that you put here. So typically, you are testing something to see if it's true, and then running a code block, one or more statements. If it is what? A code block which is one or more statements if it is true, and optionally another block of code if it isn't. You can optionally put an else block here if this one is true, so that we can actually run that block. So the else block is optional. It's not a must to put an else block here. I think we've got enough time. I think I can share with you my ID here. Where is it? I think you are actually seeing it. We have actually have the if else here. We've got the Boolean here. X is equal to is assigned the true. So here we've actually put this expression here. But what I want here, let's not use this one. Let me just declare X as an integer here. Let me say, let me put a 10 here. Then for comparing, do not forget that we need to use this double equal sign. Then let's say if X is equal to 10, so it will actually compare if X is equal to 10. You know that here X is equal to 10, then it will actually evaluate if X is equal to 10. If it is true, then execute this statement. Otherwise, execute the else block. Here, can actually say X is not equal to 10. And then here you can actually say X is equal to 10, something like this. If I run this, then it have actually shown me that the value of X is equal to 10. Why? It will evaluate this and then it will execute this block if this one is true. What if I put 11 here? And then I will execute this one. Then it will execute the what? The else part. You see that X is not equal to 10. Why? Because we have actually, let me say, okay, maybe for us, for the I think for this one to be actually clearly seen, let me just leave 10 here, then I'll put 11 here. Then it will tell you that x is not equal to what? X is not equal to 10, but x is equal to 11. Then you are comparing if 11 is equal to 10, it's a no. Then we execute the else part. So this one, this block it's optional. You can actually leave it out. There's no problem there. It will actually exit this else, this if statement, then it will go on to execute whatever follows after this statement. I think you can actually move on to other blocks. So let me actually share this previous slide that we were using. Okay, so you might have a need to nest if else statement, although again it's not recommended for readability. So nested if test should be kept to a minimum. You can actually nest the if inside your if statement, but actually it's not recommended for readability. So you can set up an if else statement to test for multiple conditions. If you want to test for multiple conditions, you don't need to actually nest the if else statement. You can actually use the else if statement. I think you all know it's the else part, the else if statement. If you say if, then you can, instead of putting the else block, you can put the else if and then else if, and later you put else statement so that you can compare multiple conditions there. So you can have 0 or 1 else for a given if, and it must come after an else ifs. You can have 0 to many else ifs for a given if, and they must come before the optional else. Once an else if succeeds, none of the remaining else ifs or elses will be tested. I think these rules, they apply to the else if statements. Maybe we can actually experiment this one so that it will be clear to everyone. Let me try to share something. Let me come here. Okay. If you want to put an else if, you don't put it just after the else part. You put it here in between your if statement and the else part. That's where you have to put the else if statement. That's where you have to put the else if statement here. Maybe you want to test if x is equal to 11 now. Then you want to do something. Sys out here. Say maybe x. Let me say equal to 11. Is there any hint?
Yes.
Okay. Can you ask?
Nasingoti network yangu here kana kuti munhu wese ari kuexperiensa zvandiri kuexperiensa maslides enyu handichamaoni.
Hausikoni ma-slides.
Yeah.
I can see them.
I can see them, yeah.
Maybe it's
I
your
can
network.
see them.
I don't know. Maybe it's your network. Or let me try to reshare again. Let me try to reshare. Are you seeing something now?
Yeah, izvezvi ndakumaona manje.
It's fine. Thank you. Okay. So I was actually explaining the issue that we're actually saying here for the else if part, that you can have a 0 or 1 else for a given if, and it must come after an else if statement. Here, you can actually not have this one if you do not want it, but if you want it, it must come after all the else if statements. Also, this else if statement must come actually in between the if statement and the else statement. So these are the rules that you have actually need to know. So I want to see that what does this one actually gives us? You see, it have actually printed that x is 11. Why? Because it first printed that it first actually evaluates this statement. Is it x be equal to 10? No. So it will come here and then test if x is equal to 11. Yes, then it will print this one. After printing this one, it will ignore the else part. Why? Because one of the else if and the if statement was actually true. But if all these failed or evaluates to false, then it will come to the else part. So this is all about the if and the else if and the else part. I don't know if there is any question there. I think we can actually move to the next slide. Is there any question? Okay, so let's talk about the switch statements. Switch statements in a Java. So the general form of the switch statement is you write switch keyword and then you put the expression here, which actually results to true, and then you put your case here, case, then constant, maybe it's case 1, case 2, case 3, or it's case X, case Y, case Z, and then you put your code of block here after each and every, you can break after each and every case, and then you give the default here, which will be actually execute if any of all these cases failed to evaluate, then it will actually goes to the default here. So a switch expression must evaluate to a character, a byte, a short, and an integer. These are accepted values, values here. So also the switch can only check for equality. It actually checks for equality. If the expression is equal, something is equal to something, and then it will execute this block. So this means that the other relational operators, such as greater than, are rendered unusable in a case. So for here, we've got this simple program, which actually uses the switch statement or the switch case. Just wait, I want to add someone here. So we've actually declared our integer variable x and actually assigned it to 3. Don't know, people who are joining now late now. So, okay, so here what it does, it comes here, we've got switch, then x here, this is this variable, and then we've got this block of code. What does it do? It chooses case just referring to this variable, then it will choose the case to run or to execute. For example, here you've got 3 here. If you pass 3 here, it will choose case number 3. So it will execute this case. Then it will print that system, it will print that x is equal to 3. And then later, and then if it actually reaches this break, it will actually goes out of the switch statement and execute whatever follows after this block. I think this is the switch statement. I don't know if there is any need for me to experiment or to just write some simple code there. Is there any need on switch statement? I think silence means that all is well. So there is the issue of break and the fall through in switch blocks. These ones, the breaks here. So the most important thing to remember about the flow of execution through a switch statement is this. Case constants are evaluated from the top down, and the first case constant that matches the switch's expression is the execution entry point. What you are saying is that it will actually start by try to match this case with this value. If it fails, it will come here, then here, then here. This is the order of testing our cases. So if it actually, when it comes here and then it will see that there is a match between this case and this value, then it will execute, it will start to execute the line that comes next. So in other words, once a case constant is matched, the Java virtual machine, the JVM, will execute the associated code block and all subsequent code blocks too. So you need to know that it will not only execute this switch statement, this statement here alone. If there is no this break, it will also execute any of the blocks that comes through, that comes here. So if it matches here to case 2, if there is no this block here, it will keep on execute case 3 and even the default. So you need to use this break keyword to make sure that it will only execute that case, right? So when the program encounters the keyword break during the execution of a switch statement, execution will immediately move out of the switch block to the next statement after the switch statement. So it will comes just down here after the block of our switch statement. So if break is omitted, the program just keeps executing the remaining case blocks until either a break is found or the switch statement ends. Is there any issue here or any question? I think I can move on to the issue of the default case on our switch statement. So the default case doesn't have to come at the end of the switch statement here. This one, this default statement that actually execute whenever there is no match between this constant and our cases, you can actually put it any, but for readability, it's wise to put it at the end after all the cases, right? So let's talk about the using of the while loop. The while loop. So the while loop is good for scenarios where you don't know how many times a block or a statement should repeat, but you want to continue looping as long as some condition is true. You know that you want to print something, but you don't know to what extent. But what you know that is that until this expression is true, I have to keep on printing this. That's when do you have to use the while loop. So a while statement looks like this. There is the while keyword, and then there is the expression here, and then you put the stuff that you want it to actually do here, or the specific task that you want your while loop to actually accomplish. For example, here we've got this while loop. We've actually declared this variable x and assigned it the value 2, and then we want to print the value of x, where x is always equal to what? Is equal to 2. So where x is equal to 2, just print the value of x. Then we are incrementing the value of x in here, and then it will loop again here, and then it will check. Once it actually becomes false here, it will execute the next line that comes after this one. So let's see how does it actually work here. So we are going to say where x is equal to 2, right? So we compare, is it x equal to 2? Yes, right? So we print the value of x, which is equal to 2. Then we increment the value of x, then it will become 3. Then we came back here and actually compare, is it x, which is 3, be equal to 2? No. So we actually do not print 3 here, we only print 2. So we come here at the end of this block, we execute whatever comes there. So in this case, is in all loops, the expression test must evaluate to a Boolean result. This one, it must evaluate to true or false. So the board of the while loop will only execute if the expression, sometimes called the condition, if this condition or expression results in a value of true. Once inside the loop board will repeat until the condition is no longer met because it evaluates to false. So it will keep on looping this one whenever this one is true. When this one becomes false, it will actually exit our loop. I don't know if there is any question on while loop. Any question there? I think I can continue. Wait, I'm trying to add someone here. So let's talk about the using of do loops, or the do while or do loops in what? In Java. The do loop is similar to the while loop, except that the expression is not evaluated until after the do loop code is executed. Therefore, the code in a do loop is guaranteed to be executed at least once. The following shows a do loop in action. What we are saying, we are asked our code, or we are asked our compiler to do something, and then we evaluate later. So this code will actually is guaranteed to execute at least once. Then we check here. So what we are doing is that we are saying do this stuff while something here is false, just like this. Or even you can say, well, this one is what is true. Maybe it's x is equal to 2 or is x equal to 3. So we are saying do this stuff while x is equal to 2, something like that. Once if x is not equal to 2, then our charge or do not do this again, something like that. So the system dot out print line statement will print once, even though the expression evaluates true, false. Remember, the do loop will always run the code in the loop board at least once, because be sure to note the use of the semicolon at the end of the while expression. Here you need to put a semicolon after this while expression. I don't know if there is any question on do loops before I proceed. Any hand? Okay, I think all is fine. Let's talk about a for loop. A for loop in a Java. So in Java, there is the enhanced one and the basic one. The basic for loop and the enhanced for loop. So let's start with the basic for loop. So the for loop is specific, is especially useful for flow control when you already know how many times you need to execute the statements in the loops block. So it's different from the while loop. Here you know the number of times that you want to loop your code. So the for loop declaration has 3 main parts besides the body of the loop. So there's the declaration and initialization of variables. Then there is the Boolean expression, which is the conditional statement that we'll be testing. And then there will be the iteration expression there. So the three for declaration parts are separated by semicolons. It's like we'll be using the semicolon, like a terminating a line. So the following 2 examples demonstrate the for loop. We've got the examples, I think, on the next slide. So the first example shows the parts of a for loop in a pseudocode form, and the second shows a typical example of a for loop. Like use a pseudo form. It's not exactly what you write in your code, but this one is what you write. So here, this is where you do the initialization. You just write for, and then you do the initialization here, then your condition here, then your iteration here. and then the board that you want to loop here. So we have this for loop, we've got this, the for keyword, and then this initialization, this is where we initialize our variable that we are going to use to loop through. So int I is equal to 0. And then here we put our condition. We check if I is less than 10. And then here we put our, increment here, or iteration here. We put our iteration here. And then this is the block that we are going to execute. So what does it actually does this? At first, it will come here, initialize the value of I to 0. And then after that, it will come here. Maybe if I use a different highlighter, or let me just erase everything. So it first actually initialize the value of I to 0, and then it will come here and evaluate if 0 is less than 10. Yes, it is less than 10. Then it will actually, it will then come here and execute whatever inside this block. And after that, it will come here. When it reaches the end of this block, at the first iteration, it will come here, and then it will do the iteration here. It will actually solve what is here, or evaluate what is here, which is an increment. Then it will increment I by 1. Then our I will become what? 1. Then after that, it will come, sorry, let me erase this. After that, I'm sorry. I've actually erased everything. I was actually supposed to pick a highlight. So after coming here, we said it will come here, and then here, and then here, and then after that, it will come here, and then after that, our I is now equal to 1, then it will come here, then it will actually check if I is less than 10, which is it 1 less than 10? Yes, then it will come inside here. So it will actually keep on repeating this cycle. It will come back here, and then here, and then inside, then here, then inside. But at first, it starts with this block, and then here, then inside. Then it will keep on doing this, something like that. So this is how this for loop works. I don't know if there is any question there. So let's talk about the break and the return and the system.exit in our for loop. What happens if we put break and return and the system.exit method? So if you put break, the execution jumps immediately to the first statement after the for loop. So in other words, if you put break, you are actually exiting the for loop. But if you put return, execution jumps immediately back to the calling method. If you put return, it actually goes back to the returning, to the method or function that actually called that for loop. And then if you put system.exit, you are actually exiting the program. So all program execution stops. That's the virtual machine shut down. So this was the basic for loop that we're talking about. So let's talk about these issues of the basic for loop. So none of the 3 sections of the for declaration are required. We can actually even leave all those 3 sections. So the following example is perfectly legal in Java, although not necessarily good practice. You can just write your for loop, and then you put nothing here and here and here. But what does it actually do? It will be an endless loop. it will be an endless loop. So in the preceding example, all the declaration parts left out, so that so the for loop will act like an endless loop. So this one, it will be an endless loop. So why do we need it for? I don't think it's not necessary there. So a for loop with multiple variables in play, you can actually do this. It will be actually also legal. Here, instead of just initializing a single variable, you can actually initialize a lot of variables here. You can also use this one, a compound statement here, or just compound Boolean expressions here that you can use, as well as here you can actually use 2 iterations here, or any number of iterations that you want here. It's also still legal. So you can put in virtually any arbitrary code statements that you want to happen with each iteration of the loop. Look at the following. This one, you can also put the code on your for loop here in these brackets. Like for example, we have actually declared this variable b, where b is equal to 3. You can actually say here you have actually initialized your variable a, and then here we are just saying if b is not equal to 1, then do something here. Then it will come back here, then it will print iterate, and then it will compare until if b is not equal to, once b is not equal to 1, it will keep on executing until b is equal to 1. Once b is equal to 1, then it will become false, something like that. So there is the enhanced for loop. This one actually use it for arrays, and the arrays is the last part that we are going to do today, and then after that we are going to look on object-oriented programming on our next lecture. So the enhanced for loop is a specialized for loop that simplifies looping through an array or a collection. You can also loop through the array using the basic for loop that we've actually done. But for you to do it easily, you can use the enhanced for loop. So in this chapter, we are going to focus on using the enhanced for to loop through arrays. Instead of having 3 components, the enhanced loop, the enhanced for is 2. It's just what? 2. So let's loop through an array, which is the using the basic method or the basic way, and then using the enhanced for here. So we've actually declared our array. You are going to do this later today. This is the way you declare and initializing your array at the same time. So we've got this array A, which have got the values 1, 2, 3, 4, and then we've got this, the basic for loop, where you can actually initialize the value here, and then you put your condition here. The length method is also found in the array class. So there is this length method, which returns the length of array. Like here we've got 1, 2, 3, 4. We've got 4 elements in our array, so it will return the size of that array, which is 4, the length of that array, and then here we increment. So this is the basic for loop that we can use to loop through our array. Then we print the values of the array here. But using the enhanced for loop, you don't need all these things. What you just want is just the array itself, and then you just declare the variable of the same type with the contents of that array, and then you just put this full colon, and then you put your variable here, and then you print this variable. You'll be able to access those values through this variable. That's all about the enhanced for loop. So the two pieces of the two pieces of the for statement are declaration, the newly declared block variable, of type compatible with the elements of the array you are accessing. This one, like here it's int, or it's an integer. Why? Because also our array contains what? Integers. This variable will be available within the for block, and its value will be the same as the current array element. So this value for n here, the value for n will be also equal to the current value that will be in this array. So you can actually access it and use it through this variable. So expression this must evaluate to the array you want to loop through. So for expression, we will actually put the array itself here. So this could be an array available or a method code that returns an array. So here you can either put an array, the actual array here, or you can put a method that returns an array, so that here we will actually have an array to loop through. So the array can be any type, primitives, objects, even arrays of arrays. You can put multi-dimensional arrays or any array of objects or of primitives type. So this is all about the enhanced for loop. I don't know if is there any need of demonstrating this enhanced for loop? Is there any need? Hello, Clemens, you can come again. I know. Hello?
I said yes.
It's okay. Which means let me share with you my IDE here. Let me remove everything which is here. Paste. What do we need here? Are you seeing my ID now? My IDE?
Yes, yes.
It's okay. So first, let's declare our array. Let me say array A, and then we put this curly brackets. Then I'll put maybe 2, a comma here, a 4, a 5, a 6. These are the elements in our array. We have declared an array and initialize it with the 2, 4, 5, 6, 7, and 8. And then you want to loop through this array, or want to actually print all the values inside that array. What you need is just to write a for statement here, for keyword, and then you need to declare the variable of that type. Since it's an integer, I'll put int, and then I can put here n, then I'll put full colon, then I'll pass the array itself. After that, what I will do, I will print. Don't, is it a question? Then what I will do here is simple. I'll just print the value of n. By printing the value of n, I'll be printing the current value in our what? In our array here. So if I execute this one, let me run this one. It will actually print everything here, 2, 4, 5, 6, 7, 8, just like this. Maybe let me print it just in a single line here. So 2, 4, 5, 6, 7, 8. You can even put a space using this string concatenation here. You can put a space between them. I think these things, you know them. 2, 4, 5, 6, 7, 8. So these are the elements in our array. We have actually managed to print this one. Even here, you can put a method that returns an array. If there is a method that returns an array, you can put that method, then it will return an array here, and then you execute that. Don't know if there is any question here.
Yes, yes.
Is there any question?
It's clear.
It's okay. Thank you. So I think I can go back to my slide. I think let's talk about the use. Can we make sure that all our mic are on mute? Okay. Isaac. Okay. So using break and continue in our for loops. The break and continue keywords are used to stop either the entire loop, which is the break, or just the current iteration, which is the continue. Typically, if you are using a break or continue, you will do an if test within the loop. And if some conditions becomes true or false, depending on the program, you want to get out immediately. Here, this is the logic. Something like maybe you are testing something within for loop, and then if that one is true or false, you just want to get out of that loop immediately, or you want to terminate that iteration and you want to start a new iteration. So the difference between them is whether or not you continue with a new iteration or jump to the first statement below the loop and continue from there. So this is the difference between break and continue. For break, you'll be actually getting out of the for loop. For continue, you exit that iteration and then you start the next iteration. So the break statement causes the program to stop execution of the innermost loop and start processing the next line of code after the block. So the continue statement causes only the current iteration of the innermost loop to cease and the next iteration of the same loop to start if the condition of the loop is met. So when using a continue statement with a for loop, you need to consider the effects that continue is on the loop iteration. If you are using this continue. So this is the end for the flow control in Java programming. I don't know if there is any question here. Is there any question on Java flow control? So as from now, we expect you to be able to write code that can do or that can perform very well.
Excuse me, sir.
Okay.
Yeah.
You can go ahead. Is it Andrew?
Yes, it's Andrew. I want to make use of the for loop in order to print out the elements of an array. But however, sometimes you may be given questions asking you to print out, for example, the mode of an array or the mode of a linked list. How do we do this?
Okay, that one you need to consider maybe the logic there in linked list, the methods in linked list itself, the linked list class itself. Andrew, can you mute your mic? I'm replying you. Okay, what we are saying here, Tim, is that in Java, you do not have a method to find the mode, right? And you are being asked to find the mode of a given array. So what we are actually asking you is to come up with an algorithm or to come up with a method or to come up with the logic of actually being able to identify the mode from a given array, which means you need to combine the methods in the linked list class itself. And then you come up with the logic that will actually end up telling us that the mode from this array is this number. So in linked list, there are a lot of methods which are there. I think we are going to do them later at later stage, but there are a lot of methods which are there that you can exploit or that you can use to actually being able to find the mode. Maybe this one, because it's also your assignment, I will not do into actually telling you exactly which method to use or what, but you need to find the list of methods in the linked list class, and then you understand how do they work. And then after understanding them, then you come up with the logic that will be actually telling us that this number is the mode from this given array list, which means you are going to use the methods like pick, there's the poll, there's the add method. You can even reshuffle your arrays in your elements in the linked list, maybe in two different linked lists or any other way that you want to do it. And you can use even the for loop, you can use even the while loop, you can use any of the flow control method that we're actually doing here. You can actually brought them into play to determine which one is the mode. I don't know if I've actually answered you enough.
Yeah, it's okay. See, I'll try my best to find out.
It's okay, thank you. And even if you check on your channel, Such Online Academy, I think they are a sort of something like that, where you're actually finding the mode from a given array or something like that. What you just want is just the logic. It's not something which is bigger there. Just understand the methods in the linked list class, and then you try to find a way out. I don't know if there is any question there. Okay, I think we can move on to arrays, and then we'll stop there. So I'll stop sharing this. Let me just wait for me while I'm opening the slide for arrays in Java. Then from there, we'll do Java encapsulation, inheritance, and polymorphism, which is the object-oriented. And after that, we'll look on to the string class and methods and constructors. We do garbage collection and exceptions and exception handling in Java. I think we'll be actually through. But also we do not forget the generics and the collection, which is actually the linked list and what blah 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 blah. Those are data structures, something like that. So let's talk about the arrays in Java. Arrays in Java. I'm actually sharing with you this window. Just wait for me. Just wait. Share window. Okay, wait. Okay, I have it. So I'm going to do arrays in Java. So arrays, we're going to talk about the array declaration, construction, and initialization in Java. So arrays are objects in Java that store multiple variables of the same type. You need to know this. Arrays in Java are objects. Even if they can take primitives, data types like integer, double, something like that, they are always objects in Java. I think we've actually talked about earlier in our first lecture, what are objects in Java. I think you understand all those stuffs. So arrays can hold either primitives or objects, references, but the array itself is always be an object on the heap, even if the array is declared to hold primitive elements. So even if you declare the array to hold the integers, it is always an object in a Java. So in other words, there is no such thing as a primitive array, but we can make an array of primitives You can make an array of primitives or of primitives data types. So let's talk about declaring an array in Java. Arrays are declared by stating the type of element the array will hold. Maybe it's an integer, it's a string, something like that. Then, which can be an object or a primitive, followed by square brackets to the left or right of the identifier, to the left or right of the identifier. So here you've got both options that you can use. You can declare your array as int here, and then you put your square brackets to the left of the identifier, like your array here would be named the key. So you can put the square brackets here, or you can just say int, then you put the identifier, then you put these square brackets here. But this one is the recommended way. But in Java, it's all legal. So brackets before name, this one is the recommended way, and it's actually readable. So declaring an array of objects references, you can just declare an array of threads objects, and this is the recommended way of putting these square brackets first before the identifier. This one is legal, but less readable in terms of readability. That's why you actually recommended to use this method. So let's talk about how do you construct an array. Here, if you want to construct an array, I think we've actually used an array in our previous code that we've actually doing when we are actually doing the enhanced for loop. So when you are constructing an array, that one that we've actually used there, that was the shorthand or the shortcut. Here, you can actually declare the array. Because it's an object, you use the new keyword here. So it's int, then you put the square brackets, and then you put the identifier, test scores, and then the new keyword, and then you write the int, then you put the size of your array here. Also, you have to know that whenever you are declaring arrays in Java, you need to give them size during declaration. So this one declares the array of ints, and then this one will also assign the size of our array. So construct an array and assigns it to the test scores variables. This is what we are doing here. So remember, arrays must always be given a size at the time they are constructed. You need to know that. So constructing multi-dimensional arrays, there is what we call multi-dimensional arrays. I think you know them from C, they are there. From C++, they are there. So a two-dimensional array of type int here is really an object of type int array with each element in that array holding a reference to another int array. Like here you have, this will be your multi-dimensional array, which will be an array of object array. And each and every element will be pointing to another array here. So the second dimension holds the actual int primitives. This one will be holding the actual primitives, and then this one will be actually holding the link to the what? To the next array. So the following code declares and constructs a two-dimensional array of type int. If you want to declare a two-dimensional array of type int, then it's int here, then two the square brackets here, and then you put your identifier, and then a new keyword, and then it is also legal just to put the size in one of these brackets. So notice that only the first brackets may be given a size. Here it is also legal to put this one alone. It's acceptable in Java. So that's acceptable in Java to put the size here. So initializing an array, it is legal because I think we've actually said that this one will be actually pointing to this array again. So initializing an array, means putting things into an array. If you are initializing, you are just actually inserting or putting the elements into that array. So these things in the array are the array's elements, and they are either primitives values, which is true, false, and so on, or objects referred to by the reference variables in the array. So if you have an array of objects is opposed to primitives, the array doesn't actually hold the objects. Just as any other non-primitive variable never actually holds the object, but instead holds a reference to the object. It will be actually holding the reference to the object, so that whenever we use that reference, we can actually get the exact value of that object. I don't know if there is any question before we continue. So the individual elements in the array can be accessed with an index. You need to know that if you want to access the members or the elements of your array, you need to know its index or its position. So the index number always begins with a 0. So in Java, arrays are zeros. Its index starts from what? From 0 or are 0 based. Okay, so for an array of 10 objects, the index numbers will run from 0 through up to 9. So from position 0 to position 9, we have actually 10 positions, which means we'll be actually having 10 elements. So suppose we create an array of 3 animals as follows. Animal, then we put our square brackets, then identifier pairs, then a new animal with the size 3, which means we've actually created an animal array which will be able to hold 3 types of animal objects. So we have one array object on the heap with 3 now references of type animal, but we don't have any animal objects. You see, what we have is references, but we do not actually have the objects. So the next step is to create some animal objects and assign them to index positions in array referenced by pairs. Like here, you can create an object and then you put it at index 0, another at index 1, and another at index 2. That's all. We have got 1, 2, 3 objects, and this is the size of our array. So this code puts 3 new animal objects on the heap and assigns them to the 3 index positions elements in the pets array. Maybe it's a dog here, the new animal. This one is another one. This one is another one of another type. Maybe it's a cat or so, something like that. So this one is also the way you declare the multi-dimensional array here. And then also this is the way you initialize them, right? You have declared this array called my array. It's a multi-dimensional with the size of what? Of 3. Then it indexes 0. You can actually put a new object there where you have actually passed 2 here. Or you can also put this one like 0, 0. You can put a 6 there, 0, 1. You can put a 7 there. At index 1, you can also put another object there. At index 1, 0, you can put a 9. At index 1, 1, you can put a 8. At index 1, 2, you can put a 5. Something like this. Don't know, I think there's someone whom I need to add here. So there is this shortcut that I've actually used earlier for declaring, constructing, and initializing on just one line. What you need is this brackets there. So you say int, then your square brackets, and then your identifier here, and then you put this bracket that is for blocks, and then you put your elements separated by a comma. So the size or length of the array is determined by the number of comma separated items between the curly braces. So the size of this one, don't need to actually pass the size of this, but it will actually, you actually passed it by the number of elements that you actually put here. So the size of this one will be actually 3. You can also use the shortcut syntax with the multi-dimensional arrays as follows. It also works with the multi-dimensional array where you have to put elements inside the curly braces, like here, this one in curly braces, this one in curly braces, this one in curly what? In curly braces. But you also work just here, the same as this way. And then from there, it will be the end of this slide of arrays in Java. Don't know if there is any question before we end our today's lecture. Thank you for participating in this tutorial. Just have a good day.
Thank you, sir.
You are welcome.